Hi, I'm Marjan Sansen. I'm a PhD student from the Architecture School in Montpellier, and I will be presenting to you today our research from Montpellier on Mediterranean morphologies in hot summer conditions and holiday housing in the glorious 30 period in France. So let's start with the introduction, shall we? So the Glorious 30 is this 30-year period just after World War II, in which a huge economic boom was happening, and also the paid holidays were installed in France. So there was a huge need for holiday housing on the Mediterranean coast, among others. All of these elements, together with the beginning of Team 10 and a reaction to the modern movement and to functional separation of cities and standardized housing for standardized men, a reaction to this way of thinking led to the existence of an experimental laboratory on the Mediterranean coast in the program of holiday housing. So what those architects were trying to do was actually to cut costs and have like more economical housing by having a repetition of the same modules or the same units and or slightly modified, but to have them repeat themselves and to make morphology out of repetition. It's called additive architecture with Jörn Utzon's words. And on the one hand, they were trying to develop this way of making morphologies in cities or villages. And on the other hand, they were trying to integrate these morphologies more into the site and to take into account the sites and the environment, sun, wind, nature, into their designs. So they are asked in holiday housing, architects are asked to think about architecture for summer, architecture for sun, architecture for heat. So they develop designs based on their knowledge of vernacular architecture. Often they use these vernacular villages as references for their designs for hot summer conditions. So, for example, the image on the left is a reference image of a book of Condilis that he uses to develop his designs for his leisure architecture. And he's not the only one. Others also mention vernacular villages in hot regions. So the hypothesis of this research is how residences of this glorious 30 period with additive architecture morphologies have a positive environmental performance during hot summer conditions, or do these morphologies really function in hot summer conditions, or were they only designed based on an image of these non-monotonous villages? How they made repetitive architecture, how can it look non-monotonous actually, and do these villages really function in hot summer conditions? So the objectives are to assess the environmental performance of 4 additive villages, morphologies, to compare them between them and to compare them to literature results. So how did we do that? There was a parallel way of working with, on the one hand, on-site fields work on the 4 additive morphologies, and on the other hand, a lot of literature study to look for the parameters that we could use for the environmental assessment. The idea is that those parameters are linked to the 4 climatological aspects: wind, temperature, humidity, and solar radiation, and to have a complete assessment and not only one of the aspects. So the parameters are absolute rugosity, compactness ratio, building density, mineralization, sky view factor, and height to width ratio, but I'll talk about them later. First, I'm going to present the case studies to you. So 4 case studies, 2 regions. This is important because the 2 regions had a very different way of developing tourism, and they have very different landscapes. For example, the Occitanie region on the left was for a long time this huge stretch of sand, very barren, very windy, a lot of mosquitoes, a lot of swamps. So the government, the French government, decided to develop this area so that instead of all those tourists coming from the north and going to Spain and to Italy, instead of passing through, they actually wanted to retain them on the site and make it into a destination. So they developed 180 kilometers of sand into a tourist destination. It were huge infrastructural works, sanitary works, etc. It's called the Mission Racine, after the name of Pierre Racine, who guided the whole procedure. And the Leucate village is one of the villages that was developed at that period, and 2 of the case studies are in the Leucate village. The Paca region, on the other hand, was developed differently and is based on private initiative and has a very different landscape because it's all rocky seashore and much more green vegetation, garrigue. So the first of the case studies is in Leucate village and was designed by George Candilis, who was, by the way, the chief architect of the whole Mission Racine, of the whole big development of the whole coastal area. So the village grec is a morphology based on T-shaped units that are grouped in groups of 4 and that are separated by pedestrian streets. So there's a common car parking and besides that, pedestrian streets bordered by hedges on both sides. There's a first floor, and in the middle of the neighborhood, there's a big esplanade of 8 meters crossing the whole section. It looks like this. So all the T-shaped sections, T-shaped units have 2 courtyards. One private courtyard that's covered partially with a shelter against solar radiation, and another courtyard that is only for accessibility. So this image gives an idea of the overall character, which is very green with the hedges on both sides. And it kind of looks like a vernacular village, actually. The second example is the Genus 2 in Leucate, which is very near to the other example, which was constructed before the Village Grec, and which is like a more easy version or a simpler version of the Village Grec. It doesn't have a first floor, it only has 1 courtyard per L-shaped unit, and the units are grouped by 10 or 12, so the blocks are longer. It looks like this. We can see a very typical pedestrian street bordered by hedges on both sides. Hedges in this morphologies are lower than the ones in the Village Grec. Third example is the Gare Benat in Bormes-les-Mimosas, built by Jean Aubert and André Lefebvre. And the main road is actually following the contour lines of the slope. The terrain is on slope, as you can see in the section and on the plan. And there's 1 main road of 3 meters wide, and then other smaller roads that are on the slope and are stairs, often stairs. It kind of looks like this. Because of the slope, the units are inserted into the slope, and they're often higher than the one just nearby. Meaning that in front here, we can see the rooftop, the green rooftop of one of the houses just in front of us. And in the back, we can see the sea, of course. The last but not least, there's the 4th case study of the Merlier in Europe, built by Louis Arache and Atelier de Montrouge, which were students of his. It's also on a slope, also has a sea view, and there are square units inserted into the slope as well. It's quite specific because they're assembled in a grid-like manner, meaning that all streets, all units are on different heights, and street widths are very different between all of them. The ground floors of the units are parallel to the slope, and the first floors are perpendicular to the slope, which makes them quite interesting units. It kind of looks like this. Again, we have the sea view, the green roofs, and the quite narrow stairs leading down and up the slopes. So the first parameter we will be looking at is absolute rugosity linked to wind and how wind is influenced by obstacles or not. So the absolute rugosity is the measure to which wind is influenced by a morphology, and it is indicated by the mean urban canopy height, which is indicated in blue on the section. The lower the rugosity, lower the absolute rugosity, the higher the main air speed entering into the morphology. Second parameter is the compactness ratio, meaning the surface to volume ratio, or the exposure of the envelope surface, the outside envelope surface, to outside environment, or to climatological aspects, to hot, heat, cold, etc. So a low compactness ratio means that less heat got lost in winter and there is less heat gain in summer, meaning that, for example, the image you can see in the center are all the underground and adjacent walls in between two buildings, common walls, of the Merlier project. Since it is embedded in the slope, all those walls are not in direct contact with outside climatological aspects. So they're not taken into account into the surface to volume ratio. The next parameter is the mineralization, or the ratio of mineral area to total area of the project, of the morphology. So since the mineral area is actually the total area minus the green area, so we're mostly looking at the green area of the morphologies, vegetation has a cooling effect in summertime due to shading and evapotranspiration. Recent literature has showed that the shading part of this cooling effect is larger or more important than the evapotranspiration effect, meaning that it is very important to take into account also tree green and not only surface green. The last parameters are the sky view factor and the height to width parameter. So what we did in our research is we used the fisheye photograph methods to measure the sky view factor of several sections in the morphologies. And although this doesn't give an overall measure, it gives an overall image, or an overall image of the characteristic of the neighborhood, of the morphology. So what is the sky view factor? Is the exposure of walls to the sky, meaning that if the sky view factor is higher, meaning that we see more sky, means that during a hot summer day, the section will warm up more easily, and during at night, it will cool down more easily. So in summertime, it is better to have a lower sky view factor, has been showed in research, if it is combined with high day and night temperature swings. So we can see in the fisheye photographs, on the right, the original fisheye photograph, and on the left, the black and white version that is used to measure the sky view factor. And even more on the left, the section of the area where the spot where the photograph has been taken. So the sky view factor is inversely related to the height to width ratio, as you can see on this graph that shows all the results of all the sky view factors taken, all the fisheye photographs taken in the 4 morphologies. So I'm just going to show you one example of the lowest values obtained, since part of the fieldwork for all the morphologies was to really look for the lowest sky view factor, the lowest height to width, the highest height to width ratio, and the lowest sky view factor. The Merlier comes out first with these examples, these 2 spots, number 2 and number 7. So you can see on the plan, they're on stairs and they're surrounded with buildings. Number 7 is surrounded with a 2-story building and a 1-story building, and the number 2 with a 1-story building and a little higher up 1-story building because of the slope. So we can see that the building height and the vegetation are decisive in the fact that it's a small sky view factor. And it's public or private vegetation, which is important as well. The bottom picture has a public tree in public area. The top picture of the smallest sky view factor has a private tree of a private courtyard hanging over the walls. We can compare the 4 case studies to each other. So the positive effect in hot summer conditions is defined by the low values for all the parameters, but for the height to width ratio, which has a positive effect in summertime for the higher value. So we can see that the Gaubinat and the Merlier stand out. The Gaubinat stands out. It's the one with the housing on the contour lines of the slope, stands out because there's less wind obstruction and there's more green, much more green than all the other neighborhoods, all the other morphologies. The Merlier stands out because it has the lowest compactness ratio because of the underground and adjacent walls. It has the lowest sky view factor and the highest height to width ratio because it has very narrow street proportions and vegetation, a lot of green. In the last part, we're going to compare the obtained values to reference values in literature. So we can see that, for example, for the compactness ratio, the additive morphologies have obtained values that are much higher than the reference values of, for example, a traditional courtyard morphology in Marrakesh that has housing of 9 meter high. Marrakesh is known for its narrow streets and its solar radiation protection during the day. So we can see that additive morphologies are less adapted to hot summer conditions than, for example, Marrakesh. But is low compacity always better? Ratti shows in his paper that higher compacity means more walls and means more heat sink if it is combined with a high day-night temperature swings. So it is interesting to see whether there are other conditions where a higher compacity can be more interesting in hot summer conditions. Concerning the sky view factor, the obtained values, again, are higher than the values of the reference. That, again, is the traditional courtyard morphology of, for example, Marrakesh. Higher values, meaning less adapted to hot summer conditions than the reference. So the streets, additive morphology, street proportions are less adapted to hot summer conditions. And last but not least, the mineralization. The obtained values are lower than the reference value, meaning that the additive morphologies are much greener than, for example, the medieval city center, the vernacular medieval city center of Toulouse, meaning that those morphologies are more adapted to hot summer conditions than the reference value. And again, we ask ourselves the question, do village centers or very green morphologies, like for example, Palmeraie, do they react to hot summer conditions in the same way as city centers? Because a lot of research is based on urban canyons and on city centers. So do they function in the same way in summertime? Can we use the same parameters? Can we interpret them in the same way? These questions are part of our ongoing study that will be completed with on-site temperature, humidity, and wind speed measures in July in hot summer conditions. These are the references we used for this paper. I thank you very much for your attention. And if you have any questions, please contact me. My email is on the first page of the presentation. Thank you.